Okay, on to page 2 of our exam review for Unit 4. Number 6, find the sum of the measures of the angles of a convex 14-gon. Remember that formula, n minus 2 times 180. In this case, n is 14, so it's 14 minus 2, which is 12. And 12 times 180 gives us the sum of angles being 2,160 degrees. Number 7, we want to find z in this right here. Well, using n minus 2 times 180, I know that n is 5. So 5 minus 2 times 180, which gives me a total of 540 degrees. That's what all 5 of these angles in a pentagon have to add up to equal is 540. So all I'm going to do to solve for z is kind of similar to number, what was that? Number 4 on this page. I'm going to add all these up. Okay, I'm going to start with p. P is 90. A is 90. T is 5z plus 18. N is 114. And E is 6z minus 3. And they all add up to equal 540. And just like number 4, I'm going to add up all the z's. I have 11 z's. And all the non-z's, which would be 90 plus 90 plus 18 plus 114 minus 3, which is 309, equals 540. Just like before, I'm going to do 540 minus 309 from each side. And I get 11z equals 231. Divide by z. 231 divided by 11. 231 divided by 11. Z equals 21. Okay, so I found z. Z equals 21. In order to find E, I just plug it in. 6 times 21 minus 3. So take this, 6 times 21 minus 3, and that should give you an answer for angle E of 123 degrees. For number 8, draw the symmetry lines of the regular pentagon. Well, you should always use yourself a straight edge. Remember, for an odd number of sides, each symmetry line is going to go through one vertex and one side. So I'm just going to go ahead and recall that as I make these symmetry lines. Vertex and side. Try to use a straight edge. This isn't ideal because I can't see. That does make it nicer. And you should come up with 5 symmetry lines. Remember, the number of symmetry lines is going to be the number of sides for a regular polygon. So there's my symmetry line. It says locate the center of symmetry. It's right there. Label it Y. Done. And then this has a 5-fold rotational symmetry. That just basically means you can turn this thing 5 times and have the vertices laying on top of each other. So if I turned it once, W would go onto O. If I turn it again, W would go onto R, W would go onto L, W would go onto D, and finally W would go back on itself. And each time I turned it, it would look the same. Number 9, true or false, each symmetry line of a regular hexagon, that's an odd number of sides, is the perpendicular bisector of a side of the hexagon. That is true. Remember, if you have an odd number of sides, I just messed up. Hexagon has 6 sides. I thought that said heptagon. That's an even number of sides. So that is false. I apologize. Remember, if it has an even number of sides, your symmetry lines are going to cut through either 2 angles or 2 sides. So not every symmetry line will be a perpendicular bisector of the side. If I had an odd number of sides, like this, every symmetry line cuts through and is the perpendicular bisector of a side. So if this was heptagon, 7 sides, then this would be true. Hexagon, even number, that's false. Number 10, in the figure BASE, angle 1 is 62 degrees. I'm going to label that. That's a 62 degree angle. Now you should recall that for a rhombus, we have right angles where the diagonals meet. So angle 2 we automatically know is 90 degrees. And then to find angle 3, we just have a triangle right here. I'll shade it in. And in that triangle, we have a 90-degree angle, and we have a 62-degree angle, so we're going to do 180 minus 90 minus 62. And that would be 28 degrees for angle 3. Number 11, last one on this page. In the space below, draw a quadrilateral that has only 2 right angles but no congruent sides. Okay, if it has 2 right angles but no congruent sides, well, okay, I can draw that. Here's my right angles. You can draw that. As you can see, I have no congruent sides. None of these are equal. But what these right angles do is they make this side parallel to this side, right there. And since I have one set of parallel sides, this is called a trapezoid. That's all we know about it. So that would be your answer for 11B.